everyone. This is Assistant Professor Ishani Trivedi from LJ Institute of Engineering and Technology. Continuing with the session regarding the precast concrete construction. As you know, students, that in the previous session we had discussed about the mixed design referring to the British standards, that is European codes, right? We also have various Indian standard codes for the precast concrete construction, but for now, so as to now, we are discussing about the British standards, right? Where the exact code of practice for the precast concrete construction. Let us try to understand today further in the same, that is the materials in precast concrete. Now we know already that concrete is always made up of, as you can see over here, we have cement, aggregate, water and admixture, right? These are the basic ingredients always followed for any type of concrete mix. But we are going to have certain materials added when we are discussing the precast concrete, right? We are going to add two more ingredients over here. One will be dry pack and another will be grout material. These two things will be added over here. Why it is required? We are going to study the same in today's session, that what are the various materials used for the precast concrete construction and why these materials are required. We know the functions of each and every element which is flashing over here right now. Cement is a binding agent, aggregate means sand is the fine aggregate, then we have the coarse aggregate. The voids will be filled up with the help of the fine aggregates in between the coarse aggregate. Water is for lubrication and for workability, and this makes your full wet mix of concrete. And the admixture are the chemicals or the minerals which are added specifically for altering or for modifying or say improving strength or any other property of the concrete mix. Let us discuss about the precast concrete mix. So the first material which we have here is mortars and grout. As I told you, student, grout is the new material which is added over here in the precast concrete construction. What is mortar? You already know that mortar is a mix of cement and sand and water, that is your mortar. We will discuss the same in detail as well. And the grout. Grout is a material, once again it contains cement, but it has certain special chemicals and elements present in it. It is one type of a binding agent. It is one type of a repairing agent as well. That is my grout material. You can clearly see the difference over here. Difference between mortar and the grout. As you can see, the grout is being filled over here in between the joints. It is a binding agent. And here you can see that mortar can be used for a vast area, for a large area. That is your mortar, a general common practice material. Next, second we have is dry pack. Now, what do you mean by dry pack? It means it is a dry combination, it is a dry mixture of cement and sand, which you can see clearly right in front of you. This is a dry pack. We will discuss why it is required, when it is required. Next we have is aggregates. Now students, I don't think that I need to go in that depth in aggregate. We have two different types of aggregate. We have fine aggregate and we have coarse aggregate. According to Indian standards, it is distinguished by the size 4.75 mm. Less than or equal to will be fine aggregate and greater than 4.75 will be coarse aggregate. They will be passing from Indian standard ISC, right? ISC of 4.75 mm. I don't think I need to go in that much depth. You already know that. Next we have is water. You know that water should be used that is liable to drink. Potable water is best suited for concrete construction. Next we have is admixture. So here, as I have discussed in the previous session, admixtures are going to be the most important part of precast concrete, which we will discuss. Next we have is steel reinforcement, right? Now you can see over here, these are your steel rebars, right? You can see that it is wrapped, helically wrapped rebars over here. This is the steel reinforcement which is to be used for the precast concrete construction. Now this steel reinforcement will be further divided into many different types which we will study. So for now, these are the basic ingredients for precast concrete, right? Remember all of them. Let us move forward. Now, next we are going to discuss the first material, mortars and grout. I am taking these together because they are kind of similarly same, but still you can differentiate it. So we are going to take it together. The first we have is mortar and grout. Now, what is a mortar? Students, you already know this. Mortar is a sand cement mix for small infill and semi-dry packing of the joints. So the joints in precast concrete construction, the joints are going to be once again very important, because you are always going to join two different precast sections and going to make up a full building or a structure. The joints, at joints, you are going to provide welding, you are going to provide bolting, and this is how your structural formwork will be ready of the precast. So here the mortar is a sand cement mix. Grout is either a cement mortar mix or a mortar mix used for infilling joints and gaps, right? The joints and gaps which we are going to deal in precast, the material grout will be used. Sometimes chemicals can also be added in grout for more binding agent or more binding property. Next, mixed design will be done according to BS EN 206, which we have already discussed. I think I have been through all of these things already. Quantity of cement, aggregate, water, admixture and additives. Additives is once again something different from admixture. If you want to add more chemicals to your precast mix, then additives will be added. 4 mm size of aggregates will be used, but it can include 6 mm size as well for wider joints, wider than 50 mm. Now, you already know that the coarse aggregate according to Indian standard codes is 10, 20 and 40 mm. Next, we have a specific British standard code over here, that is 13139, revised in the year 2002. It prefers the size of aggregate for mortar, right? Specifically for mortar, the size of aggregate as the ratio minimum upon maximum should be 0 by 2, 0 by 4, 2 by 4 and 2 by 8 mm, right? It defines it. It is defined in the form of a ratio. Likewise, we also have different standards as we already know. Next, the sieve size. The sieve size and other information is according to another code which is mentioned over here. Next, we have is the function of grout. What is the main function of grout is to fill the structural or non-structural infill. Now, the structural infill is going to talk about the beams, columns and slab, and the non-structural infill talks about the non-load bearing walls or any other non-structural elements which is not involved in load transfer mechanism. That is my non-structural elements. Somehow all these elements are going to get clubbed together, they are going to be prefabricated together, and when these joints are to be filled, then grout comes in picture, and also mortar is going to be acting as one of the infill material. Grout may be used as dry pack also, but may also contain admixture like non-shrink or expansive agent, meaning expansive agents are the types of the admixture which does not allow the mix to increase the volume, to expand, right? These agents, they allow not to shrink and not to expand. That is the type of chemical admixture. Latex bonding or be a polyester grout or equivalent added according to manufacturer's instruction. Now, these are the certain type of chemicals which can be added along with the grout, because what is your requirement? That the gaps which are infilled with mortar and grout should not expand, and because of this reason this can be specified. Okay. Now you can see over here, see, this is the joint, right? This is your column which is being constructed. At the bottom you can see that the formwork or the mold is provided. This is my bolted connection over here between the plate and the column. As I said that there will be joints, right? So this is your example of a joint between these two, and the surrounding area will be infilled with the mortar over here, which you can see. I am giving you an example that what I am talking right now, right? It will make sense after looking at this picture. So here you can see that this is my first element, this is my second element. The column and the plate are bolted together, so this becomes my connection between these two precast elements, and the surrounding area has to be filled with the mortar or the grout, that is my infill material. This is how I am talking about the types of joints and the bolted connections, the welding work which has to be done. This is what I am talking about in precast construction. Okay, let us move forward now. Okay, I'm also showing you another image or a picture over here. Let us see that, see, this is something which is constructed of precast. Let us say that this is my precast floor in the bottom. Then I have the rebars, that is the steel reinforcement. This I have as the precast wall. So you can see over here that at the bottom we have the floor, and at the top we have the precast wall which has to be constructed. So two sections are involved over here. One is floor and another is wall. Then we have the rebar. Let us talk about the lapped rebar in the grouting hole. So if I take this cross section over here, we are taking this cross section, then we can see that there will be a gap, there will be a space around the rebar which will be filled by the grout, right? Over here we can see that this portion is taken in the cross-sectional area in the figure over here. The rebar inside the precast wall. This is my rebar inside the precast wall, and around it grout will be filled, right? This will be my grout inlet. You can provide it from outer side, and at the bottom we have the protruding rebar. So it will be situated in the bottom. And then I have the lapped rebar, and in between will be filled the grout. So this becomes my infill, right? Between the lapped rebar and the protruding rebar, the space which will be left in between these two will be filled with the help of the grout, right? This is the whole mechanism of how the grout and the mortar works, and this is how the internal rebars are placed and filled with grout in the precast concrete sections. This is going to make a little bit complex to understand, but if you will look at it very carefully, then I think you will be able to understand properly. Okay. Now, workability of mortar is classified as very low with no slump, right? The mortar, it means it will be completely dry mix, right? Its slump value should be 0. It means if the slump value is 0, then the workability will be definitely low. We have studied about this in the slump test for workability. Workability of grout is specified on the construction drawings or in the method statement, and it should be high with 100 to 150 mm slump. So both of them will be reverse, both of them will be opposite of each other. Mortar will have 0 workability and the grout will have high workability. You know about these terms. If you perform the slump test, then these are the values which you get. Okay, now students, going forward to the second type of material, that is dry pack. Now, dry pack mortar, once again it is a type of a mortar or a grout itself. Dry pack, it means the workability will be 0, the slump value will be 0, it will be lesser. May be used where it is not possible to pour the grout. Now, we already saw the image in which the lapped rebars and the protruding bars in between the grout was filled. Now, if it is not possible to fill the grout which has high workability, then in replacement of that, dry pack will be used. The grout is a water cement ratio of 0.25 to 0.30, and therefore it is moldable in hand. I'm talking about the dry pack. It is placed by hand and trowel and hammered into position which removes the free air. Now if you want to see, then this is an example of the dry pack. Can you see that here this is the precast wall and it is being filled over here. This is my dry pack. Okay, so it has the water cement ratio which is very low, standard water cement ratio of 0.30, placed by hand and trowel and hammered into position. It can be once again structural or non-structural. If it is structural, then it involves the beams, columns, slab, foundation. If it is non-structural, then it involves the non-load bearing elements or the section. Next, this is your dry pack. Can you see that how if you place it in your palm and if you try to make a ball out of it, then it is going to stick together. This is your example of dry pack mortar, or it can be dry pack grout as well. Next we have is aggregates. Now students, I think aggregate is very much clear to you. Normal weight coarse aggregates are generally used. They are available from natural resources. It can be artificially made. You cannot use the aggregates which are obtained from the sea dredges, the dredging work which is done in the sea, and then aggregates are obtained from there as well, but those are not suitable. Moisture content has to be measured according to the VS code, which is 1097 part 6. Normal weight aggregate should have an oven dry density between 2000 to 2600 kg per meter cube. See, these are the specifications you are just supposed to remember. Okay. It also states that the aggregate chloride content now comes in picture, that the aggregate should not have chloride content. You know about the alkali aggregate reaction, right? If that takes place, then alkali silica gel will be formed and it will lead to expansion. So the chloride content is limited 0.2% by mass of cement. Aggregates are also checked for the reactive silica content, which I already told you about the alkali silica reaction. So silica content should be checked, which may cause unrequired expansion. Further, low alkali content should be followed, that is 0.75%, and the total alkali content of the concrete should be less than 3 kg per meter cube. This is the total quantity which we are talking about. So the chlorides and alkalis have to be taken care of when you are talking about the aggregates. Next, moving forward, we have is water. Now, water, you already know that which type of water is suitable. Potable water. Sea water should not be used. It is never permitted because it has sulfates, it has chlorides and other impurities. So mixing of water conforms to, once again, there are codes for everything. As we have Indian standard codes, the same way they have British standard codes. So the water reclaimed from cement slurry must be filtered and the cement content is calculated and specific gravity. See what it's trying to say over here, that whatever the excess of water goes away from the cement slurry can be reclaimed once again. It can be filtered and it can be reused. That is what is mentioned in this particular code of practice. You can also use crushed ice. Crushed ice can replace 50% of the mixing water, and this is one of the new, let us say, option available for you. You can use crushed ice in the place of water. Maximum particle size for crushed ice should not be more than 20 mm, right? And no particles of crushed ice are visible in the final mix. Otherwise, all the specifications remain same for water content. Next, we are going forward to the admixtures, right? Now, let us talk about admixture. It complies with the BS EN 934 parts 1, 2, 3. They have various codes for admixtures as well. The dosages are not permitted to be within the range provided that the performance of the concrete verified by the manufacturer. It means that the dosage of admixture will be specified within certain limit by the manufacturer, by the producer, and it should not be more than the feasible range. It also states that air entrainment agents and superplasticizers may be used to comply with the BS code, that is 934, as water reducing agent where total air content should be less than 6%. So what did we understand here? We have three agents. We have one air entraining agent, we have superplasticizer, and the third which we have is self-compacting admixture. These three admixture will be mainly used. They will be focused on, and the specifications are given. Superplasticizers should comply with the testing standards as well. So over here we have different type of mineral admixture. So let us say this can be said as fly ash. Then we have calcium chloride. But over here in precast, one important point: calcium chloride cannot be used as admixture, as it is going to have harsh effect on the precast concrete. Okay students, so this covers the all basic ingredients of precast concrete mix. One material is left, yes, that is steel reinforcement. We will discuss that in next session because it has to be discussed in much depth. Okay students, have a good day. Thank you.